Hey, hello there. Let's talk about today's Leetcoding challenge question, climbing stairs. It's a really classic problem, and many people, including me, the introduction problem to dynamic programming. So I think if you have CS background, you probably already know how to solve this. So I'm gonna be really brief on the explanation today. Imagine that we are climbing a staircase. It takes n steps in total to reach to the top. Each time we can either climb 1 or 2 steps. And this question is asking us how many distinct ways we can climb up to the top. So the top-down kind of approach is to take this question and try to make it a little bit more generic. So instead of trying to solve this directly, how many distinct ways we can climb up to the top, we replace the ambiguity part, the variable part, the top, by n's step or x step. And then if we have a function that can solve this, which is fx, right? Then to solve this original question, we'll just plug in n as the input to the function, and we can just return that. The rest of the problem now is basically how to figure out how we write this function fx. So to solve this, we look back at the problem. Each time we can either climb 1 or 2 steps. So the number of ways we can climb up to the x step is determined by the number of ways we can climb up to n-1, x minus 1 and x minus 2. And it's actually the summation of those two. So that's the recursive relationship, or the transition function for this problem. So if you look at the formula, it's nothing but the Fibonacci sequence formula. And there's just one more thing we need to figure out, the base case, which is when the x value input to the function is really small, that we can manage to calculate by hand directly, and we can just return that. So it actually provided us with the base case. f2 is 2, f3 is 3, f1 is obviously 1. So that's the base case. So this will definitely work. The problem is that it has a lot of duplication in calculation. If we calculate f5, it's calling f4 and f3 and add those together. Within f4 it's calling f3 and f2. So you see that f3 is calculated multiple times, and the deeper it goes, the more duplicate it has. So to avoid that, we put a memoization in there. Here I'm just using a really lazy man's memorization. Yeah, so that would be the top-down approach with memoization. So that's the top-down. To solve this from the bottom up, it's basically starting with the base case f1, f2, and then generating f3, and use f2 and f3 generating f4 until that we have calculated fn. That's the time that we return fn. That's the bottom up. Instead of from fn to look for fn minus 1, fn minus 2, we're doing from f1 and f2 and go all the way up to fn. That's the bottom up approach. So to reiterate, from bottom up, we have two values, fn minus 1 and fn minus 2. The initially f1 and f2, we just generating f3, and then we keep track of f2 and f3, and then we generate f4. After that, we keep track of f3 and f4 until that we have fn calculated. So I'm just going to call this slow and fast. The originally 1 and 1 or 1 and 2. I'm just gonna fix the number of iterations. So Actually, I'm gonna go with slow and fast 1 and 1. Slow is F0 actually here. F0 is 1. There's just one way you can stay at the bottom there. You do nothing. There's one way you can get to the first step. So I'm just gonna comment here. So the slow and fast initially are F0 and F1. So I'm just gonna update slow and fast altogether. Slow will become fast. Fast will become the summation of slow and fast. And actually I want to run this one iteration less than the input n. So that's the bottom-up approach. It's accepted as well. So the benefits of bottom-up is we can just keep two variables. So the space requirement become constant. Compared to the top-down, the recursive function calls triggers basically fn to f1 all the way back to f1, and it's caching all those intermediate results. So it's a linear space. For the bottom-up, it's constant space. But both, it's a linear time complexity. I think there is a formula to calculating Fibonacci series sequence numbers directly. If you choose that, then it's constant. It might be constant time as well, but that's generally out of the scope. I think in calculus I learned that, but how to derive that? Actually, how to derive that I learned that, but so many years out of school I no longer remember that. So yeah, this is really quick to talk about this classic questions. If you find yourself struggling, it's not really a big deal. Everybody gets stuck there when they start to learn DP, but eventually people get better. So that's the two approach. Yeah.